Electrical shock. It's the first thing people usually think of when they hear the words hazards and electricity. The intensity of the shock isn't the only hazard to consider. For example, a slight shock to a workman on a ladder could result in a serious injury. Or an electrical shock which might not kill under a short duration could result in death if the workman were caught in an electrical hold, unable to let go of the power source because of muscle contraction. Actually, just a few milliamps of electrical current can be fatal under the right conditions. When electrical current travels through your body, it can cause the heart to fibrillate, resulting in death. Or it can cause muscles to contract, and without help, you won't be able to escape its hold. In this program, we will look at ways you can protect yourself from electrical hazards. The safe work practices discussed in this program follow generally accepted guidelines for this type of work. Check your location's safety standards before performing any work involving electrical equipment. Specifically, we will discuss avoiding potentially dangerous situations, maintaining a safe distance between you and the electrical source, and using appropriate personal protective equipment. We will look at how an electrical blast can occur and how you can protect yourself against such blasts. We will also discuss the hazards of electrical arc, why it is so dangerous, and how you can protect against it. The best way to reduce electrical shock hazards is to avoid energized work. Energized work involves maintenance of on-line equipment where a blast or electrical arc might occur. Be sure any energized work is really necessary. A work order must be approved by all appropriate supervisory personnel before work is begun. Be certain you're fully prepared before beginning the job. Have all tools and personal protective equipment with you. Protective equipment includes rubber gloves, devices to tell which circuits are energized, rubber mats, rubber blankets, and other equipment which will keep you insulated from the electrical current. Know the procedure to be followed. An accurate, up-to-date one-line diagram is essential for safe work on this equipment. If you know exactly what work is going to be done, there will be no surprises when you remove the switchgear's protective covers. Place temporary insulating equipment between you and the energized circuit. Rubber gloves, mats and blankets, and approved hard hats should be worn when working with energized circuits. Let's define a couple of terms we'll be using throughout this program. An arc is a current flow between two conductive surfaces. Blast is the heat, explosion, and debris that can result from an arc. Electrical blast is a serious threat to anyone working on energized equipment. When electrical equipment fails, pressures can be generated which release tremendous force. Motor control centers should never be used for lunchrooms or for taking a break. Also, equipment should not be stored in these areas. In short, only authorized personnel performing authorized work should be in areas containing electrical equipment. Electrical components are very well designed, but they can fail without any telltale signs or warnings. Our primary consideration in this program is electrical arc, its dangers, and how to protect against it. The electrical arc is a powerful and dangerous force. The heat of an electrical arc can cause fatal burns at a distance of 3 feet and major burns at a distance of up to 10 feet. The sun's surface temperature is about 5,000 degrees Kelvin. An electrical arc can be as hot as 13,000 degrees Kelvin. The energy of the arc is not solely dependent on voltage. Arc energy depends upon the impedance of the system involved. Impedance is the measure of resistance and reactance of the circuit to the flowing current. The more arc current in an electrical system, the more dangerous it is. So even though a system may be of low voltage, if it allows more arc current to travel through it, it may be more harmful than systems with higher voltage. The maximum arc energy of a system can be defined. The maximum arc energy is approximately 1/2 the maximum fault current, or short circuit power of a particular electrical system. So there are two key points to remember about electrical arcs: the amount of energy that can be produced by an arc And low voltage systems may present greater arcing hazards under certain circumstances than high voltage systems. One of the most effective precautions against arcing hazards from energized equipment is to maintain a safe work distance. Always have an escape route should an emergency arise. The National Fire Protection Association's Standard 70E, Electrical Safety Requirements for Employee Workplaces, established minimum ranges of clear working space for energized work. These vary with the type of equipment and the working environment. A good rule of thumb is that as arc current increases, the safe working distance also increases. There is a formula for determining the required safe escape area. The effects of the arc decrease proportionally to the square of the distance. For example, if you double the distance between you and the arc source, the power of the arc will be reduced by 75%. This formula will give you a general idea of the safe area if a blast occurs. The keys to safety in working with electrical equipment, though, are wearing proper personal protective equipment, knowing exactly what equipment is involved and how to isolate their circuits. The body's ability to absorb energy plays a significant role in the severity of shock and blast injuries. Even the sex of the worker has an impact on the effects of shock. For instance, women feel the tingle of an electrical current at a lower level than do men. The let-go current level at which muscle freeze occurs is 10.5 milliamps for women and 16 milliamps for men. The cleanliness of skin also affects absorption of heat and electrical energy. Clean skin absorbs roughly half the energy as dirty skin. Keep yourself and your work area as clean as possible. Effective preparation and personal protective equipment are the best ways to reduce the dangers of electrical shock, arc, and blast. Prepare by knowing what equipment is to be worked on and how that equipment is connected to all sources of energy. Good one-line diagrams are essential for this. Preparation also involves communication. Let everyone associated with the equipment know exactly what is being done. Lock, tag, and try all remote sources of energy. Protective equipment places non-conductive barriers between you and the sources of shock and arc. This equipment may include low-voltage gloves, non-conductive safety shoes, long-sleeve shirts, or even barriers that will protect you from a blast. Flash suits can be effective if you are working on energized equipment. The key is to reduce the probability of injury. Take all reasonable and prudent steps to ensure the work can be performed safely. Safety is your most important concern when working with electrical equipment. Preparation, communication, personal protection, and awareness are essential in maintaining your safety and the safety of your fellow employees.